Welcome to qnawire.
Our question says that pancake collapse of a tall building happens in sections shown in figure 9-71A, and the infrastructure of any given floor K must be supported by weight W of all higher floors. Normally, the infrastructure is constructed with safety factor S so that it can be withstanding this even greater downward force of SW. If, however, the support columns between K and L suddenly collapse and allow the higher floors to free fall together, the force in the collapse can be exerted SW, and after a brief pause, cause K to collapse onto floor J, which will collapse onto floor I, and so on until the ground is reached. Assuming that the floors are separated by a distance of D equal 4.0 meters and have the same mass, also assume that the floors K free fall onto K and the collision lasts 1.5 milliseconds. Under these simplified conditions, what value must the safety factor S exceed to prevent the pancake collapse of the building? Okay, so we're going to solve for that. But we're going to let M be the mass of the higher floors. So by conservation of energy, the speed of the higher floors just before the impact can be given from the following. So we have the mass times gravity times the distance is equal to 1/2 mv squared. The m's cancel. Solve for v. V is equal to square root of 2 times gravity times the distance. G is the acceleration of gravity since we're in free fall. So the impulse, J, is given by delta P is equal to m delta V. Plugging in the value for V, this is m times the square root of 2g d, which is equal to mg times the square root of 2d over g, okay, which is equal to w, write that, w times the square root of 2d over g, where W is the weight of the floors. So W is equal to mg. Okay, and that's the weight of the higher floors. Thus, the average force on the lower floors, we'll call this F average, is equal to J over delta T, which is equal to W over delta T times the square root of 2d over g. But if you recall, F is also equal to W times S, so therefore S is equal to 1 over delta T times the square root of 2d over g. Okay, well, now let's plug in the values that we were told for these. So this is 1 divided by 1.5 times 10 to the minus 3 seconds for delta t. This is the square root of 2 times d. D is 4.0 meters, so 2 times d is 8.0 meters, divided by g, which is 9.8 meters per second squared. Okay, so this is equal to 6.0 times 10 to the 2. We can box that in as our solution.